Good afternoon, everyone. My name is Pratik Roychowdhury. I'm in the product management team at Juniper in the Contrail group. So today I want to talk to you about the Contrail product and some of the thoughts and trends that went behind in its creation. Just a quick background about Contrail. Contrail was a startup that was acquired by Juniper late last year. And the mission of Contrail was to solve the networking challenges that are there in cloud environments. The word Contrail means man-made cloud, and that kind of aptly defines what Contrail does. So for end customers, it helps you create private and hybrid clouds. So let me just start off, tee it up with a few numbers. These are interesting numbers. Some of these might be familiar to you, but I just want to highlight the importance of cloud and cloud networks. So 72% of enterprise decision makers say that they have already deployed cloud in their environment. There is obviously a lot of revenues, both from apps perspective and from the cloud perspective, the public cloud perspective. The next number is pretty interesting. 11 seconds is how much it takes for a virtual machine to spin up in Amazon Cloud. 15,000 is the number of servers each administrator manages in a Google Cloud environment. And 75% is the cost reduction that you get out of moving into cloud. So obviously, this talks about the time to service, the operational efficiencies, and the cost reduction that cloud brings in. And it also just highlights the fact that cloud has become an important strategy for enterprise customers. Now, what is cloud? So let me just start talking about what do we mean by cloud. Cloud is a very overused term. So this is an oversimplified representation of a traditional data center. You've got physical servers, and on top of that you've got standalone applications which run on dedicated hardware. You've got switches and load balancers and security devices. But the challenge that you see in a traditional data center is that there is an administrator who has to go and manage all of these. The system is very physically constrained, it's very siloed. The administrator needs to know details about the entire architecture. Now, virtualization came along and solved some of those problems. So now there is more device utilization because there are much more workloads running on the same physical device. It's less static because now you can move workloads across different physical devices. And one could argue that you can reduce cost because there is obviously x86 hardware that you're using and standard workloads on top of that. But then largely the problems that were there in the traditional data center, including very siloed environment, the administrator needing to go and configure each of these elements, configuring access control lists, and knowing about the entire network, that does not go away. So which is what brings us to a cloud environment. So what does a cloud do? So first of all, and you probably heard about it during the panel discussions. First of all, it takes all the resources and pools them and slices them and allocates them to different applications as and when they need. As the application scales, more and more resources are allocated from that sliced pool. There is also a centralized controller which essentially creates all these dynamic networks. And the admin just interacts with that controller, gives the controller very high-level abstracted commands such as create 2 virtual networks and join them by some security service, some load balancer, some DPI engine. And essentially everything about the network is actually created automatically. So the admin does not need to go and configure ACLs and configure policies and everything within the network. Applications can also do the same thing. So all the problems that we were talking about in case of a traditional data center and even with virtualization is kind of solved with the cloud architecture. And this is what we mean by when we talk about cloud. So essentially the network is dynamic and flexible, and there is accelerated rate of deployment of the network and the services. There is on-demand pool of resources which you can allocate to the applications, and it scales as the application scales. You have got a very distributed architecture. It is distributed not only across within the data center, but across data centers, from private clouds to public clouds. There is automated policy provisioning. So there is a controller that takes care of the policies in the underlying network. And all of this leads to lower total cost of ownership, because you are now, there is more operational efficiency, and so your operating expenses and your CapEx reduces. So one of the other things also is to note is that with this architecture, with this cloud-like architecture, applications are also reinventing themselves. They are also re-architecting. In fact, newer applications, newer enterprise applications that are built for the cloud, they have this continuous loop with the network. Essentially, they talk to the network. I mean, you might have heard terms of like network-aware applications and application-aware networking. All of that is becoming a reality. So what the application does is application asks for resources, compute and storage resources to the network, which then, once the compute and storage resources are allocated, they need to talk to each other, so the entire plumbing and the network is created. Then you have all these services such as firewalls, load balancers, which need to be put in place between those networks. And all of this creates a good amount of information, network state information within the network, and that is passed back to the application through analytics. And then the cycle of innovation continues, because applications can adjust itself based on this information. So just to highlight the point that it's not only that compute and storage and network is being disrupted, it's also the application. The entire stack is being disrupted. And initially going from a very siloed approach where things were very tied to each other, you had to have dedicated resources, to a more scale-up approach where the focus was more on performance, improving the transactions per second for applications, and you had the data center fabric in case of network, where latency was the key thing to be reduced. And now we are moving into a scale-out, distributed, flexible kind of an approach, where the storage is distributed, the network is automated and highly distributed, and applications can make use of this flexible and distributed architecture to using big data analytics and some of the self-service models. Which is what brings us to Contrail. Now, what does Contrail have to offer? Right? First of all, Contrail has tried to help customers move away from very configured and managed network to a very automated and orchestrated network. It has moved away from hardware-centric kind of services to more of virtualized on-demand pooled services. It has moved away from private infrastructure to a cloud-like architecture, which involves not only multiple data centers, but it could be data center and a public cloud like Amazon Web Services. And finally, it moved away from the walled garden proprietary approach to a much more open approach. We use open standards like Border Gateway Protocol, BGP, which is a very standard routing protocol that is used in the internet today. And we also interoperate with a number of open source components such as OpenStack, CloudStack, Zen, KVM, and so on. But the most important thing to note here is that the complete product is open sourced. And we do have a commercial version of it, which comes with support. But in terms of the product, the commercial closed source version and the open source version are exactly identical. So, any networking presentation, you will find a set of slides which talks about the planes. So here it is for Contrail. At the very bottom layer is the network virtualization layer. So that is what we call as the overlay network. Essentially, it sits on top of the physical infrastructure, And what it does is, behind the scenes, it just creates tunnels between different endpoints. And this is what creates those virtual networks that I was talking about earlier. Now, those virtual networks need to be joined with virtualized network and security services like load balancers, firewalls, and so on. And that is the next level. Now, you might have heard about a term NFV, Network Functions Virtualization, which is pretty popular in the service provider world. And that is the layer that enables network functions virtualization. So all these load balancers or firewalls are network functions. Now, on top of that is the control plane, which offers network programmability, and that is the controller that has the brain of the entire network. And this layer exposes REST APIs to the higher layer, which is the orchestration layer and the analytics layer. Applications can utilize those REST APIs to basically program the network. Now let me show you the architecture of Contrail. And the reason I like architecture is because this, as you will see, this architecture was inspired by time-tested architectures of a router. If you dissect a router, you will see that there is a set of routing engines which east-west talks BGP or OSPF or some standard routing protocols. There are some line cards which basically east-west talk some standard MPLS or GRE or some of the standard data plane protocols. And between them, there is a message bus. There is a bidirectional message bus. Northbound to the routing engines, in any router, you will have CLI or SNMP and so on, right? Now, if you look at this architecture, this is exactly the same. The control component, which is the Contrail controller, talks BGP east-west, and that is exactly how virtual networks can actually talk to physical networks. Southbound, it talks standard protocol XMPP, which is Extended Message Protocol, and this is where a lot of companies use OpenFlow to talk from the Contrail controller to the so-called line cards or the x86 devices. And northbound, it talks REST APIs, so standard orchestrators such as OpenStack and CloudStack can actually talk to the network through that. So as you can see, we have just taken time-tested architectures and applied it to Contrail. Now, what it allows you to do is create this overlay network, so you can have multiple networks, which some of them might belong to cloud. Some of them might belong to marketing or HR, and you are connecting them through firewall services or load balancing services and so on. And if you have your own VLAN-based legacy infrastructure, you can actually connect it using a standard router. It could be a Juniper router, it could be a competitive router, and doesn't matter, so long as it speaks BGP, you can essentially use that. So obviously the product is very much interoperable because we use standard protocols. Now, let me talk a little bit about some of the use cases that you can get out of this, right? So the first use case, as I already mentioned, is if you want to create your own cloud-based data center, which is virtualized, you can go from a traditional VLAN-based data center to a much more cloud-based data center. And you can have all these virtual networks created dynamically, and you can connect them using different services, load balancing or firewall services. And obviously the benefit of that is that you can run new kinds of applications which are created for the cloud. Those kinds of applications you can run on your new network, and you can keep running your legacy enterprise applications on your VLAN-based network. So the next use case actually talks about how do you combine the two. So you have got an existing infrastructure which you obviously cannot get rid of. And so how do you use the new cloud-like infrastructure and still be able to use your existing infrastructure? And as I mentioned, we use standard protocols, which is why you can actually extend either portions, like for example, you can extend your VLAN 2 into a cloud. And to do that, you just need to do a minor configuration on the MX, on the router, saying that this VLAN goes to this virtual network. And we represent the virtual network by a routing instance within the router. Or you can actually extend your entire infrastructure into a cloud-like environment. So obviously this gives you the benefit of being able to run your legacy applications as well as your cloud-based applications in the same infrastructure and be very much interconnected with each other. The third use case is where you can have like an enterprise private cloud, your own private cloud, which you have created using Contrail, and you can connect it to public clouds, for example, Amazon, and you can move workloads between the two. So you can have marketing workloads or HR workload being moved between the two. And finally, we have another use case which we are calling as the dynamic service chaining. So when you create a network, you've got the front-end network and a back-end network, tiered network, and you are connecting them using some minor policies. Now, what you could also do is say that I want a set of services to be chained and be connected between these two virtual networks. And you can do that using Contrail, and these services could be virtualized services, it could even be physical services. So obviously that creates business processes that you might want to enable. So hopefully that was helpful for you to understand about Contrail. We have got a lot of tons of information on opencontrail.org. As I mentioned, it is now open sourced and is available for you to download and play around with. Obviously, we have a commercial version that offers support. You can go to juniper.net/SDN, and there you will find lots of white papers, demo videos that talk about Contrail and how you can utilize Contrail in your own infrastructure. And please feel free to reach out to me. My email address is there, pratik@juniper.net, or other folks, Derek and others, you can reach out to. And let us know, irrespective of what stage you are in your decision-making process, please do let us know what you think about it. Thank you so much.